Hello, welcome to this talk about the MACS toolbox, which was crafted by my colleague Soch Allefeld and me. So if you're working with fMRI, especially if you're analyzing your data with SPM, maybe you have previously thought something like this. I don't know how to model my data, or should I include this regressor or not? Or how do I model reaction times? What processes of no interest should I include? Or maybe even my modeling decision is based on observed effects, which is certainly not a very good situation. But if you have ever thought something like this, don't worry, there's a solution, and solution is called the MACS toolbox for model assessment, comparison, and selection, which is available from GitHub and about which we have also written a paper. So before we start, we should maybe ask what kind of models are we talking about when we say model assessment, comparison, and selection. So we are here talking about voxel-wise general linear models for fMRI data analysis, in which, as you probably know, the volt signal from a single voxel, here given as the vector y, is decomposed into variation from experimental conditions and potential confounds, which are collectively referred to as the design matrix X, weighted by some regression coefficients beta, plus some noise, which is always in the data and which we cannot decompose using our model. Okay, so next, what kind of methods do we apply to those models? So in the past, we have developed cross-validated Bayesian model selection, or CVBMS, which allows to identify voxel-wise optimal models for first-level fMRI data analysis, and cross-validated Bayesian model averaging, or CVBMA, which can improve parameter estimates by combining the information from multiple models according to their likeliness. So in a nutshell, you can say that the MACS toolbox is these two approaches, CVBMS and CVBMA, and a range of other tools, which are here shown on the right. So this is the complete list of methods included in the toolbox. And as the name of the toolbox says, they fall into three categories: model assessment, model comparison, and model selection, where model assessment can again be subdivided into goodness of fit measures, such as R squared and signal to noise ratio, classical information criteria like archaicus and the Bayesian information criterion, and methods based on the Bayesian marginal likelihood, for example, the cross-validated log model evidence. Then we have methods for model comparison, such as voxel-wise log-based factors, and methods for model selection, for example, group-level Bayesian model selection. So then what kind of features does the toolbox offer? First, we have a manual and an automatic processing mode in the toolbox. What does it mean? So in the manual processing mode, you would take the single SPM.mat from a single model as an input and supply it to some operation and then get some output. In the automatic processing mode, you would first collect all the SPM.mats from all models applied to all subjects, and then define a model space file ms.mat, which can be used as an input to several different operations, basically all the features that are implemented in the toolbox. And you then get the output for each model applied to each subject automatically. Of course, you can also use the manual processing stream. So this structure is implemented for model assessment, model comparison, and model selection. And in addition to this, we have tools for voxel-wise visualization of high-dimensional data. So for example, if you want to have a look at the time series, at the entire time series of a single model and review its fit to this time series, or if you want to have a look at parameter estimates or several posterior probabilities while browsing through the brain, you can do this using those tools. If you are a beginner with fMRI or SPM, don't worry. The MACS toolbox is completely integrated into SPM's batch editor, so you can, if you want, specify all your processing jobs by hand. If you are an intermediate user, you are of course invited to use the standardized pipelines included in the toolbox for Bayesian model selection and Bayesian model averaging, which exist in script and in batch form. And finally, if you're a developer, you can easily extend the toolbox as it is fully documented, as shown in this diagram. So As we have seen, we have tools for model assessment, model comparison, and model selection. And each function is either a batch function communicating with SPM's batch editor, or an interface function parsing the information to the neuroimaging analysis, or a purely mathematical function that is just performing some statistical operations. And this is the way how the entire toolbox is structured. So you always have a batch function calling an interface function, calling a mathematical function. And this is here detailed for all the methods implemented in the toolbox, such that you always know which function is calling which other function. So with that, I want to say thank you. And if you want to know more, click on the link in the description to access a free PDF of the paper. So thank you very much.